Okay, third problem. Let's see. 2 text 78. Decide if each pair of triangles below is similar. So recall that similar means that all the angles are going to be equal. Or that all the sides, if we don't know the angles, although we should be able to figure those out, all the sides are the same ratio to the other sides. Okay? So in other words, if you took the triangle and you kind of increased it, like scaled it up, it should equal eventually the other triangle. Okay? So that's what similar means. So if the triangles are similar, justify your conclusion by stating the similarity condition you used. Also, describe a possible sequence of transformations that would carry one onto the other. If the triangles are not similar, explain how you know they are not similar. Okay, so A. So recall again, and we can actually probably Google this, so if I just look this up, similar triangles, there's probably a Wikipedia page or something that'll show us, let's see, similar geometry. Let's see, here we go, similar. Okay, two geometrical objects are called similar if they both have the same shape or one has the same shape as the mirror image of the other. More precisely, one can be obtained from the other by uniformly scaling, enlarging or reducing, possibly with additional translation, rotation, and reflection. So, if two objects are similar, each is congruent to the result of a particular uniform scaling of the other. Okay, so let's see. So what does it say about triangles? Anything about triangles? Triangle. Okay. For example, all circles are similar to each other, which makes sense because all circles, if you shrink one circle down, it becomes another circle. All squares are similar to each other. Well, that makes sense because all squares have exactly the same side, and so if you just scale it up, you get all possible squares. And all equilateral triangles are similar to each other. Well, yeah, because all their angles are the same, and then if you scale them up, you'll get all other equilateral triangles. Okay? All right. So you can read about that if you really wanted to know a whole lot more. But let's go back to our homework here. Okay. So first problem. Angle this, well, whatever this angle is congruent with that angle. This is 90 degrees and that's 90 degrees. So the only other angle is this one. And since it's shared by both of these two triangles, we know that all three angles of each triangle are congruent. Well, if all three angles are congruent, then the two triangles are similar. They're not congruent triangles because one triangle is obviously smaller, and congruent would require that the sides be the same, but they're definitely similar triangles because if you just scale this triangle up, you will eventually get this one. Cool. All right, so that was A. So now B, equilateral triangles. Well, as we just saw, by looking over here, it flat out says all equilateral triangles are similar to each other. Equilateral triangles, both similar, done. Okay, ooh, all right, here we go. Now we got a tricky one. So we've got two triangles and some different side measurements. So what I'm going to do is I'm just going to draw them out here. So let's see. Get rid of this. Let's take this thing and let's draw it out. All right, what do we got here? We got a triangle. Some weird shape, right? Kind of like that. Kind of. Not really. How do I move this? Kind of like that, maybe. Kind of. All right. Maybe a little bit bent. Okay, there we go. All right. So now I'm gonna write my numbers on here. So let's go 6 over here, 11, 11 over here, and then 8 right there. And then we've got this other funky looking triangle. Let's see what this thing. No, it's kind of like that, but it's more like that. All right, so we've got that triangle. Boom, triangle. Okay, and then we've got 15 over here. Okay, and then we got 20 over here. 20. Okay, and then we've got 33 over here. Okay. What Well, this is a little tricky for me, so why don't I just rotate them so that they're kind of the same? Because I can't really see them when they're like weird like this. So let me move it like that. Woo! Okay, that's a little hard to read. Move it like that. All right, there we go. That's a little bit easier to read. Not great, but let me turn them. Can I turn the numbers? Yeah, there we go. Let's turn those numbers. Woo! All right, look at that. Boom. Okay. All right. Let's move that one a little bit over. There we go. Okay. So we've got 6, 8, and 11, 15, 20, and 33. So let's see if these are similar triangles. Well, here's an easy one. If they were similar triangles, then I should be able to take. So 11 is 1/3 of 33, right? In other words, I take this number, 11, multiply it by 3, and I get this number. So I should be able to do that for all sides if they're similar. Like if I just scale this triangle up and it's supposed to equal the one over here, then I should be able to scale it up equally. So that would mean 11 times 3 is 33, 8 times 3, oops, should be 24, and 6 times 3, oops, should be 18. These are not similar triangles. Okay, so C, nope, fail. Okay, let's look at D. Alright, again we got some weirdness. Let's see if I can draw that one out here. Well, I'll just clear all these out, I guess. Okay, let's try it again. New triangle. Let's do that. It's kind of more like that, ish. Okay, and then what do we got in here? We got scribble. Let's do 60 degrees here, right? 60. Okay, that's that one. We got 50 over here, right? And then since we know that they add up to 180, 60 plus 50 is 110. 180 minus 110 is 70, so this one must be 70. 70, right? Cool, that adds up to 180. So then we've got this other triangle. So let's see what this triangle looks like. Triangle, I said. Triangle. Okay, that's not a triangle. What is it doing? Triangle. There we go. Okay. And then, I'm gonna like rotate it a little bit, like maybe like that. Okay. And then maybe I'll just scale it up just a little bit so it's a little bit easier to see here. Alright, now, what are they telling me now? So they're saying this one is 25. 25. Point. They're saying this one is 30. 30. Okay, and then that means that 25 plus 30 is 55, right? And then so 180 minus 55 is going to be 125. Is that right? 125. Okay. Well, come on, guys. These aren't equal, or these aren't similar triangles. No way, because if they were similar triangles, all the angles would have to be equal. The angles aren't even close to equal. Come on, man. Alright, so those are not equal, obviously, or not even similar. Let's see what they say. Find the measures of the unmarked angles. You really don't even have to do that, right? They're trying to trick us because they're like, ooh, that's half of 50 and that's half of 60. Well, for the angles, it's not going to matter, because you're going to find that missing angle and it's going to be 125 degrees. That's silly. First of all, the triangle doesn't even look like this then. The triangle looks like something weird. Looks like, how would the triangle look? The triangle's going to look super funny. Because this angle here has to be like huge. It has to be almost 180 degrees. This is giant. It's going to look like, man, how do I even make that angle? It's going to look like, I don't know, something like weird. I don't even know how you make that angle here. Oh, yeah, well, kinda. Like, maybe like that. No, not even like that. Oh, well. However it looks. Let's see if, could I make something like that? Let's see. So it needs to go like way, no, that's a right angle, or a right triangle. How do you make one of those triangles? I'm just being silly now, but let's see. So you'd have to like, there we go. That's kind of what it looks like. That's more like it. Because see, that's like 125 right there. Center back. Yeah, there we go. So that's a little bit closer. Because this is like 125 now. Man, what a weird triangle. That's no way that's similar. Anyways, okay, cool. Done with that problem. Done, done, done.